For some reason, the record is stopped. Okay. Now, I explain que using function notation. Okay, suppose the parabola, I don't know. Let's see example now, guys. Suppose one parabola like that. This point, is the point in which the parabola across the y-axis is the y-intercept. It always is 0, c. And c, remember, and the standard for ABC, c is that number. Okay, so this is the advantage. This is super useful. The standard for, because you see clear who is the y-intercept. And x-intercept, well, it's different. You take the f of x, in our example is 8x squared plus bx plus c. You enforce it to be equal to 0. Plus c equal to 0. You enforce it to be 0. Entonces, in this moment, you have the quadratic equation. Entonces, the thing that we are doing when we solving the quadratic equation is find the x-intercept. Of course, what is the formula? Bueno, the formula is quadratic formula. The quadratic formula. That the value for that point is the classical quadratic formula. I don't want to copy again because you know very well. Entonces now the new thing is advantage and disadvantage. Standard is good when you want to find y and x-intercept. And vertex for is good, very good when you want to find the vertex. That's an important point. Okay. Let me try to apply to find the relationship between A, B, C and A. Well, A is equal to A, H and K as a function A, B, C. Okay, look, it's like a conversion, no? Standard from standard to vertex going opposite direction. No? Okay, let me go again. We have y equal ax squared plus bx plus c. This is a standard. I copy it now. The vertex form gets exactly the same. It's ax minus h squared plus b plus k. Sorry. And repetition again. H comma k represent the vertex. And the vertex is this famous point. H comma k. Well, there are many ways to prove that. However, the easy way, in my opinion, is you multiply here to apply FOIL. Let me try here. X minus h times x minus h. Entonces, x times x is x squared. X times h is minus xh. Again, inner product is exactly the same. There's no coincidence because they are twin brother, plus h squared. Plus k. This is x squared minus 2xh plus h squared plus c. Now, multiply. So I remove the parenthesis. Because what is my goal? My goal is compare this and this. So it's ax squared minus 2xh a plus ah squared plus c. Look at that. This guy, I forgot here. X8, x squared. So multiplication, this and this, this and this, this and this. Now you compare, listen this, look here. Oh, this and this. Es obvio que B, es obvio que minus 2HA, que es the coefficient with the X is equal B. Therefore, B is equal minus B over 2A. Minus, so H is equal, sorry. Hello, what the hell today happened? So for h is equal minus b over 2a. And this is super important formula that we are using today. Now the rest is C. Okay, sorry, this is K, right? Okay, the rest is this guy. I'm going to use another color. Es equal to C. Okay, entonces the conclusion is C is equal A H squared plus K. Entonces we use manipulation and substitution H for that value. I get the K value, and the K value is equal to C minus B squared over 4A. And this is another formula to find K. And we're using that formula to do the conversion in between standard. It's from standard, because I suppose I have A, B, and C, and we convert to vertex form. Huh? Okay, I bring 3 examples to illustrate very, very well. So we are doing the corresponding manipulation, conversion from one way to another way, and doing the graph in Desmos, because in the test I asked you the graphic of this. Okay, I want to raise the ball, guy. Look. Okay, let's go to example 1. Example 1. Example 1 is f of x is equal minus 2 parentheses x minus 1 squared plus 8. The question I have is, this is expressed in standard or in vertex form? Come on, answer me. Standard or vertex form?
Vertex.
Say again?
Vertex.
Exactly, very well, vertex form. Immediately you recognize, okay, vertex form, look like that, look at that, A parenthesis x minus h square plus k, ¿no? Es obvio que A es negativo. Es obvio. Compare both. Es obvio que h is equal 1. Because the formula inside the parentheses we have a minus, so there's a minus here. There's one shortcut to find quickly what is the value for the h is, so you see inside the parentheses negative 1 actually is positive 1, so opposite sign. However, k is different. Why is different? Because it's plus. It says plus k directly, k is equal 8. Okay. No, now, okay. After the class, any question that you have problem in the homework, you let me know. Okay, I solve it for you. Okay, what is the procedure? Remember, the question is different for any students. Entonces, si I open in my platform, I see different examples. So you take a picture, the specific example I want to solve for you, send me back by email. I solve in one piece of paper. I take a picture again. I send to you. Okay? This is the way to study. Okay? Okay, entonces let's continue with the lecture. Entonces, I can see clear. Wow. In what direction open this parabola? In what direction open this parabola? In what direction open this parabola? In what direction? Open. We have 50-50, up, down. In what direction up? Up or down?
Down.
Down. How do you know it's down? Where's the glue? Give me information it's down.
It's less than 0. A is less than 0.
O sea, A parameter, A value is negative. Therefore, This indicates us que this parabola up and down. Very well. Up and down. Because A is negative. No B, no C, no H, no K. It's A. The control of the what direction open the parabola is given by A. When the A is negative 2, it's up and down. Okay, I have another question. Where is located the vertex? At what point is located the vertex? At what point is located the vertex? At what point is located the vertex?
1,8.
1, A, very well. In other words, H, K. The formula for the vertex is always H, K. Entonces, I take advantage que my given equation is expressed in vertex form. Entonces, I take directly 1 and A. End the story. O sea, that famous point, que es super important, is 1, A. And I know que my parabola up and down. Okay, that's it, no? We need more information. We need at least 5 points or 3 points. I have only 1 point and also direction. So the important points are y and z. Y and z, remember, you evaluate the function as 0. Unfortunately, our equation is not expressed in standard because in standard is super easy because you take only c and that's it. One, okay. I plug in 0. So minus 2, 0 minus 1 squared plus 8. Negative 1, 0 minus 1 is negative 1. Negative 1 squared is positive 1. Positive 1 times negative 2 is negative 2. And negative 2 plus 8 is 6. And the point is the point 0, 6. This is one way to do that. Another way, or another point, are the x and z. The x and z, remember, the formula is f of x equals 0. This is a mnemonic device to remember. What is the formula? I don't remember the formula for finding x and y and z. This is the formula, guys. Using function notation. This is the useful application of the function notation. Okay, so now I copy my expression, que es minus 2 parentheses, x minus 1, square plus a should be 0. I am forced to be 0. So in this moment, I have a quadratic equation. I solve the quadratic equation, and that's it. Let me try. I move 8. In this case, I take advantage that somebody do the factorization. So it's better doing by square root. So I copy minus 2, x minus 1 square equal negative 4, equal negative 8, sorry. Because I move to the right hand side like a minus 8 divided by negative to both sides. I have x minus 1 squared equal 4. Apply square root both sides. X minus 1 without square and square root, you know, gets canceled. Is equal to square root 4, get plus or minus. Don't forget dollar sign too. Let me continue here. Therefore, x alone, solve for x, is plus or minus 2 plus 1. Entonces es 2 plus 1, que es 3, and minus 2 plus 1, que es negative 1. Entonces we have 2. We have 2 x intercept. Is the point 3,0 and the point negative 1,0. With this information, I suppose it's enough to start the graphic of this. If you need more points, because basically in this point, in this moment, we have 1, 2, 3, 4 points. In order to find the 5th point, we can use in axial symmetry, no? Okay, axial symmetry. Axial symmetry is the line, the vertical line, axial symmetry is the vertical line, x equal h. Okay, h in our example is 1. Okay, it's a line to split the parabola into equal. Let's see in Desmos to see more clear. I open Desmos now, guys. Look. Okay, let me switch it to Desmos. Okay, look at that. Okay, you see Desmos?
Yes.
Okay, look at the example 1. Example 1 is y equal minus 2 parenthesis x minus 1 squared plus 8. Let me try to do the graph of this. Boom. Look at that. Look at that. Look at that. So far, we discover parabola up and down. So far, we discovered also. Okay, nice. Okay, we have one vertex, que es 1,8. Okay. We have one y in a set, que es el point 0,6. And we have two x in a set, que es negative 1,0 and 3,0. If you want to find additional point, we can, because this dotted line, vertical line, represent the axial symmetry, que split perfectly the parabola into equal part. Therefore, I can see que using my common sense, no mathematics, only common sense, we have another point here. It would be, this is 1, this is 2, 2,6, I suppose. Look, 2, this is 0, 1, 2, 3. This is 2,6, 2,6 because it's the same distance, that the distance from the axial symmetry to this point is 1. I don't care if it's in opposite direction. This distance is positive number. And the same distance in the right direction is 1. Entonces 1 plus 1 is 2,6. Let me try. So we have an additional point using symmetry is 2,6. Boom. And we have the famous 5 point, and that's it. Any question? Any question about the parabola? No? Okay. Okay, let's go again to the whiteboard. Whiteboard again. Let's move on to the example 2. Example 2, bring me a new situation. Bring me a new situation. Example 2. Example 2. Okay, sorry. And now? And now, miss? Or mister? Yes, okay, super. Okay, the example 2 is f of x, again, is equal 3x squared plus 12x plus 5. And my question is, this is a quadratic function. The clue to understand this quadratic function is because we have this square, right? It's a square. Give me the information that is quadratic, no? But this is expressed in vertex form or in standard?
Standard.
Standard, very well. In standard, I know that A is 3, B is 12, and C is 5. Suppose I want to find, for example, one. Okay. Number 1 is looking the sign of the A, que is positive 3. I know that my parabola open, in what direction open? Open up, open down?
Up.
Open up. After that, open up. After that, open up. The famous important point, is the point H, K. I have no idea. Because in standard it's super easy to see in vertex form. Sorry, in standard no. But I know the formula que state the relationship. Suppose H is equal minus B over 2A. It's the formula que state relationship between A, B, C, in this case, and B and A and H. Entonces super easy. Es minus B is 12, multiplication by 2 times 3. Entonces, minus, we have only one negative sign. 2 times 3 is 6. 12 divided by 6 is 2. Negative 2. H is negative 2. In order to find the K value, you apply the formula, but in my opinion, it's easier. And that way, look at that. You evaluate automatically, you using function notation, and you evaluate F and negative 2. Because I want basically K is the Y value for the H. So remember, the vertex, we have two values, two components, no? Is H comma K. And what is the relationship between these? K is the Y value associated with the X. This is X and this is Y. Okay, entonces 3 times, no necessary formula, negative 2 squared plus 12 times negative 2 plus 5. Entonces I put in my calculator, no? Or not necessary calculator, because look at that, negative 2 squared is 4. And 4 times 3 is 12. This is minus 24 plus 5. Because 12 times, this is to say minus 12 plus 5. The answer is negative 7, no? Negative 7. Very well. Entonces I discovered que my parabola open up, but the vertex is located at the point negative 2, comma negative 7. Okay, nice. Let me try now to find the y-intercept, no? And x-intercept. Okay, y-intercept and x-intercept. Okay. Just a typical point, no? In order to find the y-intercept, it's super easy, because I take advantage that this original was expressed, look at that, in standard. Entonces I know that when this situation happens, y-intercept occur in 5. Let's see. Is the point 0, 5. Always 0, 0, C. In general, is 0, C. In particular, in this example, CF5. Okay. And x-intercept always is a little bit more complicated, because basically the thing we need to do is solving the quadratic equation. So the quadratic equation, guy, look, the thing we are doing when you're solving the quadratic equation is find the x-intercept of the parabola. So in other words, is the point when the parabola crosses the x-axis. Okay. In this case, it's a little bit confusing, but no problem. I apply the quadratic formula. So A is 3, B is 12, and C is 5. Okay, I repeat again this idea, but not necessary. You apply the quadratic formula. The quadratic formula is minus B plus or minus square root B squared minus 4AC divided by 2. And our specific example is minus 12 plus or minus square root 12 squared minus 4 multiplication by 3 is A multiplication by 5 is C divided by 2 times 3 is 6. 2 times 3. Let's compute the part inside the radical. The part inside the radical is 144 minus 60, no? Okay, 4 times 3 is 12, 60. When you're subtracting this, the answer is 84. 84. Unfortunately, 84 is no perfect square. That's okay. That means our solution is irrational. And don't worry, because we use a calculator, no? The basic is minus 12 plus or minus square root 84 divided by 6. We can manipulate a little bit, but no. Let's go directly to the point. I copy minus 12 plus radical 84 over 6. Minus 12 again, minus square root 84 divided by 6. I put in my calculator. Yeah, I compute the approximation using 2 decimal places, nearest hundredth. And the first one is negative 0.47, and the second one is minus 3.53. Therefore, we have two x-intercept, que es the point, negative 0.47, because the y component is 0, no? I create intentionally. Look, y component was 0 here. Was y component. And minus 3.53, 0. Okay, super. So far, it's no big deal. How many points in total we have in that moment? We have the vertex, 1, 2, 3, and 4. We need one extra. Okay, we using the symmetry. But no, before that, I want to determine the axial symmetry. Axial symmetry. Axial symmetry is x equals something. And its value, okay, in our example is -2. And also important in the application that we study after that. Suppose, in this case, the parabola. This parabola open up, no? How do you know it open up? Because A is 3. A is positive. Entonces, when this situation happens, we have in the vertex, we have a minimum. Totally opposite situation happen. See the parabola open down. So we have a maximum here. So we take advantage this fact in the application problem in which, for example, you want to investigate something and you need to optimize. Optimize means determine minimum or maximum. It's the best, independent of the problem, no? So you find the vertex always. So the minimum value, in this case, the minimum, how do you know it's a minimum? It's a minimum because my parabola open up. See, open up, we have a minimum. Occur at the point exactly in the vertex, que es h, k. Pero en k, in our example, is -7. Entonces, at y equal -7. This is the minimum value of the parabola. And the parabola open from -7 to +3. And curiosity now. Let me introduce one idea. Domain and range. Domain and range of that function. Well, the domain always in the parabola is all real number. Why? Because we have no restriction. Remember, restriction we have only when you have denominator is 0, you avoid to be 0, and square root, okay, you avoid the expression inside the radical negative. So it must be non-negative because it is negative, you know, it's imaginary, right? But in this case, no radical, no nothing. It's nice function, all real number. However, the range, no. The range go from -7, que es the minimum, including -7, to infinity. Positive because the parabola open up. So basically, is from this to this. Different maybe situation happen when the parabola open down. Is from this to this. But actually sería minus infinity to h, k value. So k value in this case is from k value to positive. Okay, not bad. Let's go. Let's move on now to Desmos because I want to see the graphic and complement it with the extra 0.5 point that we need. Let me go to Desmos. Boom, 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 boom. Do you see? Okay, that was the previous example 1. Now example 2. Do you see Desmos guy, right?
Yes.
And example 2. Okay. Well, I copy here in Desmos, I copy in the vertex form. It's okay. It's okay. Let me see. Okay. The parabola open up. Look. The vertex is a point -2, -7. Look here. the y-intercept is the point 0.5, and the x-intercept is the point negative 3.53,0 and negative 0.47,0. Exactly, we predict using the quadratic formula. Well, you can see now, look at that. Let me highlight the range. The range is this region, look. Boom. Is from negative 7, gets the vertex, to positive 3. This is the range. Domain is always all real number because the parabola open in both directions. Okay? To the extremely left, to the extremely right. The all real number. The parabola have no restriction. The domain is all real number. By curiosity, let me put the original equation. I put it here the vertex form. But suppose I put curiosity, I put y equals something, y equals, I type in the original, it's 3x squared. I'm using the keyboard for Desmos. Plus 12x, no, plus 12x plus 5. Plus 5. Okay. Let me change the color because it's red. No, not red. Let me use maybe black. Black color. Do you see that there are perfect coincidences between the equations? Okay, the red and the black overlap. Look at that. Let me show you. Let me put on enable the black. It's the red. The red, black, red. So black, red. It's exactly the same. These functions are equivalent. It's the same. It's the same parabola. Okay, super. No problem. Everyone follow me? Confusing? Clear? Let me know, guys. Remember, remember, today you need to send me the test on paper. Don't forget and submit the test online. Any question about the test online and the homework, let me know. I can help. I can help only in the test too. In another test, no. Okay. Let me see. Let me check it, guys. Stop. Okay. Do you see the whiteboard? Yeah, right? I suppose, no? Good. Let's go move on to example 3. Example 3 is very, very interesting. Example 3. Okay, and example 3. We have the function like that. F of x is equal minus x squared plus 4x minus 5. Okay, it's quadratic function again. It's the family of the parabola. Actually, it's a parabola, of course, with transformation. But I need to identification if you express it in standard or in vertex form. Standard or vertex? Vertex or standard? Question mark. Answer me.
Standard.
Vertex?
Standard.
You say vertex?
Standard.
Standard. Okay. Standard. Very well. Entonces, immediately you recognize who is A, B, C, no? A, B, and C. Who help me? A is? Who is A?
-1.
-1. And what happens when the A is negative number? the parabola que represent the graphic representation for that function open in what direction?
Down.
Open down, because A is negative number. The only parameter, ABC, que have the responsibility to in what direction open the parabola is A. I don't care B, I don't care C. Well, I care, but for another thing. But in the direction is only A. Open down. Super. B is 4 and C is -5. Okay. Okay. Suppose I want to find immediately the vertex point. Okay, I know que normally is called H, K. Entonces I use the formula, H is equal minus B over 2. This is the most important formula today, guys. Entonces es minus B. B is 4. 2, A is -1. Ooh, be careful. We have two negative. Double negative. And double negative, I know it's positive. So the final answer. See, we have one negative, negative. You have two negative, positive. You have three negative, negative. Okay? In this case, we have only two negative, negative. So actually, is ignore the negative. So 4 divided by 2 is 2. H is 2. In order to find the K value, well, you evaluate the function and 2. Okay, it's the H value. Because K, I know is the Y value associated with the H. So minus 2 square. This minus here. Be careful with the sign because it's not the same minus 2 square and minus 2 square. Actually, we are doing this. Minus 2 square plus 4 times 2 minus 5. Okay, and this is minus 4 because 2 square is 4. The minus and the front stay. Plus 8 minus 5. Then negative 1. And negative 1 because negative 4 and negative 5 together is negative 9. 8 minus negative 9 is negative 1. But the vertex occur at the point 2, -1. This point. I know that the parabola open down. Because A is negative. Okay, super. Now, I need more point. The famous point is y-intercept. Because the function evaluated 0. But in this case, super easy. Because I know that when this is present in standard, I know it's the value for the C, and value for the C is -1. Therefore, the point is 0, -5. It's the y-intercept. And the x-intercept, I have no idea. I need to solve in the quadratic equation like that. Minus x squared plus 4x minus 5 equal to 0. Because I have no idea. I use it one more time the quadratic formula. Quadratic formula is minus b plus or minus square root b squared minus 4ac divided by 2. And our specific example is minus 4 plus or minus square root 4 squared minus 4 multiplication by a, que es -1, multiplication by c, que es -5, divided by 2 times -1. Okay, let me compute the part inside the radical. This is 16. Be careful with the sign because we have 1, 2, 3 signs, 3 negative signs. Entonces es negative. Definitely es negative. This is 20. This is -4. And the square root -4 is imaginary. Entonces I want to say something important in algebra. When you try to find something imaginary, when you try to find something that you consider useful, you consider it important, and you discover that the answer is imaginary, it's because this y-intercept I try to find doesn't exist. Okay? So this parabola, we never cross the x-axis. Okay? 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 Maybe it's clear, maybe not clear. Let me try to see in Desmos. Okay? In Desmos. Okay? Let me switch. Switch into Desmos. Okay. I suppose you see Desmos now, right? Yes or no? Okay, let me put it example 3. This is example 3. Look at that, look at that, look at that. Example 3 is, okay, it's a parabola that open down, open down, open down. Look, this is the vertex, okay, 2, -1. We found that point, okay, was the y-intercept, okay, 0, -5. We discovered also okay, the x-intercept do not exist, and make sense now, because if the vertex is located at the point 2, -1 and the parabola open down, it's obvious that the parabola never crosses the x-axis. So the interpretation, the algebraic interpretation, when it's complex or imaginary, is because do not exist. The point that you try to find, the point that you're looking for, do not exist. Okay, so you have only 2 points. Wow, I need more points. So 1 point, well, okay, you using the symmetry. In this case, the axial symmetry is the vertical line, y equal to, because it's a vertical line passing through the vertex, and the distance between the axial symmetry and this point is 2. Look at that, 1, 2. In the opposite direction, 1, 2. So it's 4, -5. So the same y component is -5, but the x component is now 4. Where I come from 4 is 2 plus 2. This 2 gets h, plus these 2 gets the distance. And we have 3 points as acceptable, and that's it. This is the graphic of the example number 3. Any question, guy? Something confusing, something weird, something that you don't understand very well, or everything is clear? No? Come on, come on. I want to hear opinions. Clear, confusing. I don't understand anything. I am totally lost. Okay. Let's go. Clear? Question?
Yeah.
Go ahead, go ahead. I don't hear very well. So your microphone or the communication or the internet doesn't work very well. Well, you can use the chat, no? To express your opinion. Clear, no clear, confusing. Come on, come on. Who say something? Try again. Come on. Everything okay?
I don't know if we can do one again because it's not too clear for me.
Wait, number 1 example, you say? Number 1.
Yeah, can we do it
Okay,
again?
okay. Why? Because you was late. No, it's okay.
Yeah.
It's okay. It's okay.
Oh,
It's okay. Why? It was number 1. Repetition number 1 again. Y is equal -2 x minus 1 squared plus 8, ¿no? Entonces you realize immediately que yo exprese en vertex form. No standard. No standard. Because you compare in your mind this idea. A x minus h squared plus a plus k. And you can see clearly that a is -2. Look, compare. H is +1 and k is +8. So you determine that our parabola open down because a is negative, and this point is the vertex is 1,8. Okay? We continue. In order to find y-intercept, you evaluate the function in 0. So in other words, replace x for 0 to say -2, 0 minus 1, square plus 8, 0 minus 1 is -1. -1 squared is +1. +1 times -2 is -2 plus 8. The answer is 6. And the point is 0, 6. Okay, this is a y in a set. And the x in a set was relatively easy because you take the original function, you enforce it to be 0. Look at that. And you solve the quadratic equation. Look. But I take advantage. Some people expand this binomial. No. Much better solving like that, using a square root. You take, for example, -2, parenthesis, x minus 1 squared. I move a to the other side, divided by -2 both sides. I know que -8 divided by -2 is +4. Now apply square root both sides. It's a classical algebra. We have plus or minus 2. Therefore, x alone, isolate x here, is plus or minus 2, plus 1. Because I move this -1 to the right-hand side like a +1. But actually, we have 2 plus 1 gets 3. Using the positive sign and using the negative sign, is -1. You have 2 points, get 3, 0 and -1, 0. Let me try roughly, no Desmos, to do the sketch of this. Look, roughly, quickly. This is our rectangular coordinate system. The vertex is located at the point 1, 8. Look at that, 1, 8. 1 here. This is x-axis, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here. This point is 1, 8. Get the vertex. I know that the parabola open down. But I know also that the y is 0,6. 1, 2, 3, 4, 5, 6 here. This point is 0,6. And also I know that the x in the set is in 3, 0, 2, 3, 3, 0, and -1 here. -1, 0. Okay, entonces I suppose que my parabola look like that. Look. Okay, remember the parabola is a smooth curve. My sketch is not good because actually the parabola never have a corner like that. It's smooth like that. Okay? But when I try to do my best. Okay, now we discover another point here. Que is symmetry with respect to the axial symmetry, que is this line. Okay, by the way, is the line x equal 1. Because h is 1, no? Yeah, h is 1. And this distance is 1, and this distance is 1. So this distance is 1, so this point is the point 3, 2, because 1 plus 1 is 2,6. And that's it. This is my graphic in the example number 1. It's okay, sir?
Yes, thank you so much.
Okay, my pleasure always. Okay, let's move on now to the application. Because in the test number 3, you see 2 questions. Que is do the graph. But you have another question que is the application. Let me try to explain two applications. Okay, I have it here. Okay, the first application is like a geometry application. Application number 1. Application 1. Okay, the problem talk about Okay, a parking area. We have a parking area. Is to be constructed adjacent to the road. Period. The developer has purchased 340 feet of fencing. Entonces, the question, the problem is determine dimensions for the parking lot that would maximize the area. Bueno, okay, and also comma, find the maximum area. Maximum area. Wow, noise. Okay, let me try to explain, because one image is much better than thousand words. Basically, we have road here. And they want to construct a parking area adjacent to the, okay. So this look like a rectangle, no? But the rectangle have 3 sides, not 4 sides. Because I suppose it's the car here, okay? We have to get inside the parking lot in that direction. Or in that direction. Okay? And my goal is try to find dimension, but we have restriction. We have some restriction. When we have, I call this segment like an X, and this segment is also the same. My sketch is not good, but it's the same. And this is Y. So you normally in the word problem application, no? Basically when this is geometry part, you try to make a sketch to understand the problem, and you declare some like a variable. So I can see that my problem basically is a rectangle. The rectangle has 3 sides, not 4 sides, because this is open. But the first restriction that the developer imposed to you is the fence. The fence is the perimeter. Perimeter is the distance around the figure, but the figure have only 1, 2, and 3 sides. So this side and this side is the same as 2x plus y. And this is equal, the problem say 340, sorry, feet. And the area is the objective. So my attention is focusing in the area. The area is this surface, no? Is multiplication x times y. This is my problem, and this is my equation. Let me try to manipulate something. And then I need to find the maximum area covered under that condition. Okay, to solve that problem, we have, unfortunately, 2 variables, x and y. I need to convert this problem to variable and only one. So you solve for y, for example, not necessarily like that, but I did it that way. You solve for y is equal to 340, 340 minus 2x. Okay, you move 2x to the right hand side, subtraction. Okay, now my area is equal multiplication x times y, but y is 340 minus 2x. And you, why not apply this distributive property here and here is 340x minus 2x squared. So the area, let me copy, but let me copy in other way. I realize, wow, it's a quadratic function. How do you know que es quadratic function? Because this point indicates us que es quadratic function, right? Entonces, immediately, I organize in that way, minus 2x squared plus 340 x, and that's it. Entonces es quadratic function. Okay. Actually, this quadratic function is expressed in standard, no? Because I don't see parentheses, no, standard form. Therefore, I realize que A is negative 2, B is 340 in this specific problem, and C is missing. No C is 0. This is the mathematical model, but our problem is like that. It's a quadratic function. By the way, this is a parabola, yes or no? This is a parabola. And this parabola open up or open down? Up or down?
Down.
Down. How do you know it's down?
A is negative 2.
Because A is negative, very well. Entonces, look here. This point is the vertex, you know, it's a maximum. It's exactly they want to find, the maximum area. In other words, this problem of the optimization applying the quadratic function is always find the vertex, and that's it. Okay, and what is the formula? The most important formula that we studied today is H is equal minus B over 2A. Okay, let's do it. Minus B, who is B? 340. 2 times A is negative 2. Wow, double negative again. Double negative become positive. And 2 times 2 is 4. And 340 divided by 4 is 85 feet. How do you know it's feet? Because my problem is talk about feet, no? Feet. But this represent, remember, H always is associated with the X. Okay, X is that. So I suppose that this dimension is 85 feet. This is also 85 feet. Y, well, Y, I have no idea, but I have equation that state the relationship. Look at that. I take advantage of this equation. Say I know X value, I want to find Y, que 340 minus 2 times 85. This is 170 feet. This is the Y value. This is 170 feet. Okay, so what is the maximum area? Well, my maximum area is multiplication X times Y. Who is X? 85. Who is Y? 170 feet. And when you multiply this, it's 14,450. In this case, feet is square because it's surface. Okay, this is one application of the quadratic function. So you realize que the parabola, you realize that this parabola up and down, so you need to find the maximum. Okay. Any question in this application? Clear or no? Or confusing? Okay. Let me ask a question. Some students here took physics or physics in the high school? No?
Yeah, I did.
You took? Physics,
Yeah,
physics
I saw the
without calculus.
index.
Physics without, oh, okay. Without calculus, not necessarily calculus. Physics, just physics. And your major, you need to take physics. I do, okay. Melin is she do physics. To say, you talk about, you talk about, you talk about projectile motion. Projectile motion. Okay, let me projectile motion. Okay, yeah, projectile motion is famous. Suppose projectile motion. Suppose we have here one building. This is a building. This is the window of the building. It's another window. And you have in the top of the building a cannon. You launch the bullet. And the bullet describes a parabola. And here hit the floor. Boom. Okay, the trajectory of this is the parabola. And the physics help me to understand so many of the velocity. Okay, this vector indicate velocity, initial velocity of the bullet. I call V null, V zero. But in any point here, any point x comma y, who is x and y? X is the distance. Look, the distance is x. It's a horizontal distance from the point you launch the bullet, and the y is the height. Okay, and describe perfectly the trajectory point by point of the projectile motion. No? And the equation are y is equal h null. H null is the distance of the building, H null, H0, plus B0YT minus 1/2 the gravity, que the gravity in our planet is 9.8 meters per second square, T square. Actually, it's the parabola. You see square here again, a quadratic equation. This is the equation for the y, is the height. And the equation for the x is easier, is B0xt. Because we have one initial velocity, but we can break it down, this vector into vector. B0x is the velocity in the direction x, and B0y is the velocity of the direction y, and B0 alone without x and y is the total vector, no? Okay. Suppose one a hypothetical example in which the height of the building is 10. Is 10. 10 meter, I suppose. Is 10. And suppose que we break it down on the vector and do vector, don't worry for this. And this is 7.07, sorry. That the component, because the angle, I suppose hypothetically the angle is 45 degrees, it's the inclination for the cannon, entonces 0.70. Entonces si you suppose que the initial velocity es 10, si you suppose que V null es 10 what, meter per second. Si you suppose que the angle theta is 45 degrees, B0x is 7.07 is equal B0y. It's the same. Minus the gravity is 9.8 divided by 2, 4.9 T squared. And this is the equation that describes the motion in the y direction. No? And the x direction is easier. It's 7.07 because it's the same component T. And this is the set of the equation we need to analyze to describe the motion of the parabola. Okay. So what is the question? Well, the question is, there's some question. For example, the first question is determine the maximum range. Maximum range. What is that? Okay, the maximum range is that distance. Look at that. The distance from this, the building, to the point when the bullet hit the ground. This is the maximum range. Okay, I want to find exactly in what point impact the ground, hit the ground. Okay. And also curiosity. Let's try to find the maximum height. Maximum height. Okay, here, that distance. But this is extra. The most important is the maximum range now. The maximum range. The most important characteristic of the maximum range is hit the ground. See, hit the ground is because y is 0. Okay, no height. We are on the ground. Y is 0. Y is 0. Entonces you take the equation for the y, you impose to be 0. And my equation is 10 plus 7.07t minus 4.9 t squared equal to 0. And this is the quadratic equation. Yes or no? So basically, if you want to find in what point the bullet hit the ground, is find the x-intercept. Well, actually we have two, no? But one x-intercept is stupid because this is a parabola, no? And this have no sense because the parabola start in this point. And that part have no sense, only this part of the parabola. Okay. Entonces I apply the quadratic formula. I don't want to complicate your life using the stupid number. But I did that. Yeah, I find t. T is the time. T is time. And when you solve in this quadratic equation, you get two solutions. No, always you get two solutions. The first solution is t equal negative 0.878. And the second solution is t equal 2.321. This is second because it's time, no? It's second because it's time. But they have no sense because it's negative. And this, I suppose, que es this time, que es in the part que have no sense because we start the problem here at t equals 0. This is t equals 0, and this is t equal negative. It's a past, have no sense. This is completely nonsense. And this is t equal 2.321 second is the time in which hit the ground. T equal 2.321. Okay, if you want to find the maximum range, get the x value associated with this time, you plug it in, x equal, you multiplication 7.07 times 2.321. And the answer is 16.41 meters. In this case, it's meter because it's the distance here in meter, right? Okay. This is the maximum range. Okay, guys. But and I want to verification that this answer is correct. So I bring for you now today a simulation of this, but not in Desmos, using another simulation for the projectile motion. Okay, let me try to share the screen for the sim. Okay, switching to that. Okay, boom. Do you see or not? Do you see the simulator?
Yes.
Okay. Let me try to impose the condition. Okay, the building is this building. No? The distance is 10 meters. 10 meters. That's okay. The angle of the cannon is 45 degrees, like that. The initial velocity was 10. Do you remember 10? 10 meters per second. And the maximum range was 16.41 something. 16.44. There you go. Okay, I hit the ground. I hit the launch the bullet here. Boom. Exactly. I got it. Do you see? Any question? This simulator you can find internet. Repetition again. Repetition again. You erase here the trajectory if you want. Repetition again. And this is very, very critical. See, I make a mistake. For example, I using another parameter. You don't hit that. Look, too much velocity. Not enough. Okay. Any question? Any question? Do you understand or don't understand? Okay. So we spend the rest of the time we have to start a new topic. This new topic is no quadratic equation anymore. No. It's another topic. It's rational function. Okay, let me make it sure. Okay, put the whiteboard again. Okay, whiteboard. Switch it to the window. Whiteboard. There you go. Okay, the topic we start get too long. We start now, but we continue Wednesday. It's about the rational function. Okay. Okay, definition first. Rational function by definition is the division to polynomials. So f of x is equal p of x divided by q of x. And p of x and q of x both are polynomial functions. Okay. It's important to say something. Q is not zero because you know what happened perfectly when the division by zero is undefined. So it's totally illegal. Okay, so the first thing you should do when you face rational function is a factorization. Factorization what? Factorization both polynomials. Factorization the polynomial at the top and factorization the polynomial at the bottom. I bring 4 examples to illustrate this idea. Look, example number 1. I have a function. Okay, function. Okay, we have factor 4 function. Factor 4 function. So after the factorization, and by the way, domain. Okay, always is important. By curious, domain, factor 4, and the function. Example number 1. Example number 1 is f of x equal 1 over x. Wow, it's a reciprocal function. It's a particular example of the rational function. Well, 1 is a constant. 1 is the polynomial degree 0. And x is a linear degree 1. Okay? The factor form is identical because we cannot do anything. We cannot do anything. 1 x is x. In another example, you see yes, it's possible. And the domain is obviously all real number except 0 because 0 is the only restriction division by 0. And you can indicate like that from negative infinity, comma 0, no include 0, union 0, comma infinity. This is the domain. Do you understand very well the elementary first example? The original is given, the factor form, in this case, it was impossible to do anything, and the domain. Let's move on to the second. Second, I suppose, is more interesting. Is 5x squared divided by x squared minus 5x plus 6. Okay, it's given like that. Polynomial degree 2. Polynomial degree 2. And g of x in factor 4. Well, in the top, we have monomial. And monomial stays the same. But in the bottom, no, we have trinomial. And the trinomial open two parentheses is easy, regular. Okay, these two do not belong to this is the degree 2. It's x, and the combination is 3 and 2. Because 3 times 2 is 6, it's somehow 3 plus 2 is 5, the sign is negative of. Exactly. The domain is a factor 4. The only thing I did was factorization. The only polynomial is possible factorization was the polynomial in the bottom, no? Now the domain is, well, all real number except the bad guy, and the bad guy in this problem is 2 and 3. So one picture to understand that situation is, this is my all real number line. Look at that, minus infinity, plus infinity. 0 in the middle, but happen que 1, 2, and 3. So we have one whole in 2, one whole in 3 is a bad guy. Now the domain is all real number except the restriction is from negative infinity to 2. Let me copy. From negative infinity, comma 2, union. We have another piece, a small piece here, I guess, from 2 to 3. Union, and the last piece is from 3 to infinity. This is the domain. In other words, domain is all real number except the restriction is 2 and 3. Okay? It's different to the function we studied at the beginning today, because the domain for the quadratic function is all real number, and the rational no. No. Sometimes yes, but sometimes no. Suppose another example. Suppose h of x is equal x plus 3 divided by x squared plus 4. Okay, polynomial in the top is a linear, degree 1. Polynomial at the bottom is a quadratic, degree 2. And the factor 4, and the top, impossible, because already it's prime expression. But in the bottom is also, look at that. Suppose that we have x squared minus 4. Oh, it's a difference of a square. And the factorization is the classical x 2, plus or minus, no? But you know that when it's plus, it's prime. It's impossible factorization. Okay, entonces leave it like that. Leave it like that. And let me try to investigate domain. And let me try to investigate the restriction. Actually, the polynomial in the bottom is prime because you try to solve this quadratic equation, surprise, look at that. You force it to be 0. Okay, let me try move forward to the other side, minus 4, square root both sides. X is equal plus or minus, and square root negative 4 to y, it's imaginary. And remember my recommendation, when you're in algebra, you try to find something, and the answer is imaginary or complex, it's because do not exist. And this is also the reason that this expression is prime. We cannot do factorization. Then, remember, when you have division, and the restriction is the expression at the bottom to be 0, it's impossible in the real field. Now, domain is all real. Why? Remember the agreement to find the domain. The agreement is, I suppose in any function, okay, the domain is all real number except restriction. But the restriction I try to find, que es the denominator equals to 0, is imaginary. And imaginary means que do not exist. So we have no restriction. Therefore, the domain is all real number. Clear? Okay. Number 4. Number 4, P. P is the name of the function. P of x is equal x squared minus 11x plus 30 divided by x squared minus 9x plus 18. Okay, this is the given function, no? Okay. Entonces, the first thing que you should do always in this problem que involve radical rational function is factorization. You express it in factory form. This is step one, always. Okay, so I try. Factorization trinomial, degree 2. Okay. Trinomial. I open 4 parentheses. Put 4 times the variable, que es x. Okay, and the first, I suppose que 6 and 5, because 6 times 5 is 30, and 6 plus 5 is 11, no? Entonces minus. Like when this sign is positive, we expect the same sign, both negative. And here is 6 and 3. 6 and 3. 6 and 3, and again negative both, right? Okay. Okay, but in this case, in this particular example, look at that. Something special happened. The reason I bring that, this factor is cancelled. And you get this expression, okay, it's x minus 5 divided by x minus 5. Okay, it's easier than the original, and we can manipulate much better using this than this. However, what is the problem? Okay, this expression is not 100%. No. It's 99.999% equivalent to this. Why is not 100%? Because you delete 6. But this is valid if under the supposition that x is not 6. See, x is 6, we cannot delete this because 0 times something divided by 0 times something, any 1, any 2, you cannot cancel out that 0. Okay? And this is a mistake. This is similar to the thing we are doing in the equation. Remember, we have restriction and you delete some solution. Okay, entonces, in few words, in few elementary words, I have the complicated expression. Okay, you factorization. And see, you have common factor, you delete the common factor, you cancel out the common factor. So I know that this statement is true. Look, x squared minus 11 plus 6, 11x plus 30 divided by x squared minus 9x plus 18 is equivalent is this symbol, equivalent 100% of this gets easier, and that restriction. So this is valid for any number, but not in 6. Now this statement is completely true, 100%. Okay. But this is not the important thing. The important thing is, what is the domain of P? What is the domain of P? Oh, I have no idea. Domain of P. Okay. Again, I draw a real number line. What is the reason I draw a real number line? Because the professor in the test want que yo express the domain in that notation, interval notation. So to see more clear, at least for me, you write like that. This is 0. And we have in 6, we have one problem. 1, 2, 3, 4, 5, 6 here. Here in 3, we have another problem. Look, because 3 minus 3 is 0. 1, 2, 3. Basically, in 3 and 6, we have restrictions. My domain is from negative infinity to 3, don't touch 3. 3 to 6, don't touch 6. And from 6 to infinity. The domain is negative infinity, 3, union, 3, 6, union 6 comma infinity. This is the domain of this, the original, que es given in the problem. However, you know que this, que es the easy way, the easy version of the new one, of the original, the domain is just 3. So the domain of this, let me using another color. Let me using another color. Okay, another number line for try to find the domain of this. Negative infinity, positive infinity again, 0 in the middle. Okay, we have entry 1, 2, 3 here. Entonces, domain is this part. We have a hole here, and we continue here. The domain of this in green color is from negative infinity, comma, 3, union, 3, comma, infinity. So the only bad guy is 3. We have a hole in 3. In this case, no, we have a hole in 3 in 6. So this is the domain for the original. But if you in the middle of the process you want to work it with the new one after the simplification, keep in mind, introduce this idea. Okay, 6. But when you put and this, you put the second hole here, it's exactly the same of this. Do you understand the idea? It's confusing, eh? Very confusing. But don't worry, be happy because we are working every day from today using this idea. Okay, domain simplification. But the most important is when you face one problem of the rational function, immediately you factorization the polynomial at the top and factorization the polynomial at the bottom. And you cancel out. So to start the problem, the first step, the step 0, is eliminate any common factor. But of course, you keep in mind that you suppose and that. Okay? Okay. And the 5 minutes that we have, any question, guys? Confusing? I suppose it's confusing. It's just the initial. Okay. Let me try to introduce one new idea. This function, rational function, always have acid. This is a new word. Acid. In plural, acid. What is that? Asymptote is a line, it's an auxiliary line can help me to understand the function. We have different kinds. We have vertical, we have horizontal, and we have slant. Okay. The easier to understand is vertical. We cannot study everything today. No. Vertical is something like that. Entonces now you are doing like a vertical line, but always dotted line. Because this is auxiliary to understand the function. And suppose the function, well, this is the x-axis. Suppose this is the x-axis. And suppose there are different possibilities. Suppose que the function approaches pero never touch. Never touch. Suppose this is one possibility. There are several possibilities, guys. This is my function. Approach pero never touch. Vertical. Horizontal, no. Horizontal is like that. Horizontal. Entonces, the function, this is the f of x. Okay, we are studying. The function also approaches and sometimes touch and seldom touch. I want to explain in detail Wednesday. But approaches and sometimes touch, pero seldom touch. This is my function. But a horizontal line. Okay. And by the way, I forgot to say that the equation for the vertical line is x equals something, no? Suppose A is that value. A is that value. And the equation for the horizontal asymptote is y equals b, and b is this value. And slant, more complicated. Slant is something like that. Look, it's a line. No horizontal, no vertical. I say oblique line. And the function may be approached, suppose like that, but never touch. And the equation of this line is the classical equation that you know, y equal mx plus b. Now we have slope, we have y-intercept. In this case, the slope is 0. Is 0. And y-intercept b. And here slope is undefined. Undefined. Because in the vertical line, we have no slope. Okay? And we study in detail. Next class, asymptote. This is the topic because asymptote is a line, hypothetical line that we are using like a tools to do the graph of the, similar to the idea for the, in the parabola, no? The parabola, we using to understand much better the axial symmetry. Do you remember that, right? Axial symmetry. So we're using asymptote and rational function. Rational function continuation, Wednesday at the same time. Rational function. And today, don't forget to submit the test on paper. And submit no. So send me by email the test on paper and submit online in Alex the test number 2. Any question that you have about the test is weird. I know that they are weird questions and we have not enough of time to solve this. Don't hesitate to ask me, but only one. No 2, no 3, no 4. So you select the best that you understand and I solve for you. Okay? Okay? Super? No problema?
Professor,
Go ahead. Please, go
most
ahead.
most of these problems involve substitution in some way, right? When putting
Yes.
it,
Yeah.
putting the numbers, then you still have to rationalize it to get the interval, the correct interval, right?
Okay, I don't understand very well your question. Your question is about the topic we cover now, or the question is about?
Yeah. The top. Yeah.
Pero the thing we have in the whiteboard now, or no? The acid.
That's right.
Okay, don't worry for this. You don't understand very well now, but I promise we are doing several examples of this. Okay? Don't worry. You focus it 150% in your test on paper and submit the test online. I send the book, the work quiz into email. Okay. Don't worry. Today my day is try to solve the problem for you. Okay, bye.